Let us discuss carbonyl compounds. In the carbonyl compounds, we will go for a benzylic acid rearrangement. In the benzylic acid rearrangement, we will take the compound like cyclohexane. Now alpha diketone we are we are taking alpha diketone. Okay. It is treated with what in the sense OH minus. It is treated with base. So OH minus is given. Now, what is the first step in the sense OH minus is attacking carbonyl carbon. OH minus is attacking carbonyl carbon, this pi bond shifting to oxygen. Now here double bond O we can write. Here we can write O minus, here we can write OH. This O minus is having 3 lone pairs. Sorry. What is the next step? How the next step is possible, we'll see. What is the next step, we'll see. Here, this carbon, it is having 2 hydrogens like this, we'll take. This lone pair is migrating here. This bond is shifting here, which is attacking here. This bond is shifting here. Okay. Therefore, this 5-membered ring becomes a 4-membered ring. 5-membered ring becomes 4-membered ring. This double bond O becomes O minus. This carbon is having this C double bond O OH. C double bond O OH. Okay. Then it is base, it is acid. Therefore, H plus is transferring. So we are getting here it is OH. It is a COO minus. COO minus like this we will get. Okay. So that here a ring contraction takes place. Ring contraction takes place. So we will take another compound now. Like this compound we will take. Here one keto group we will take. Here one keto group we will take. This is alpha diketo. This is what in the sense alpha diketo. Now we will take a base. Tertiary butoxide base we will take. Tertiary butoxide base we will take. Okay. Now this tertiary butoxide has to attack carbonyl carbon. Which carbonyl carbon it will attack out of these two? Which is more reactive that it will attack? Sir, which is more reactive? Here this carbon is having partial positive charge, oxygen is having partial negative charge. Here also carbon is having partial negative, oxygen is having partial negative. Now, it will attack which one? That we have to see. For that case, we have to see the neighbors. Here, this methyl group is there. It shows this methyl group can show plus I effect. This methyl group can show plus I effect. Methyl group is electron donating group. Therefore, magnitude of positive charge is less here. Magnitude of positive charge is more here because no plus I effect here at this carbon. At this carbon, no plus I group. But at this carbon, plus I group is there. So that here more positive charge in the sense for this reactivity is more, for this reactivity is less. Therefore, this carbon is more reactive, this carbon is less reactive. So now this O minus is attacking this carbon instead of this carbon. Then this bond is migrating like this. Okay, here double bond O will be persisting. Here we can say this double bond O becomes O minus and the tertiary butoxide we can say here. So, what is the next step? We will see how the next step will be there. In the next step, what happens means this O minus becomes a double bond O. This lone pair comes here, while this bond pair goes to this carbon. This carbon attacks this carbon. This pi bond shift here. Okay. Therefore, this 5-membered ring becomes 4-membered ring. 4-membered ring. This is becoming O minus. O minus. This O present at this carbon, neighboring carbon is having methyl group. That methyl group we have given. This carbon is having this C double bond O. That carbon is having C double bond O. This carbon is having this tertiary butoxide OCMe3. Okay, like this is there. So and so compound we are getting. Okay, in benzylic acid rearrangement. So next reaction we'll see. We'll take ethyl group. Here a cyclohexane. Here methyl group. Here one ketonic group. Here one keto group. Now base we will give OH minus base we will give. Base will attack which carbonyl carbon? This base OH minus will attack which carbonyl carbon? Now, which carbonyl carbon is more reactive? That means here methyl is there, here ethyl is there. This ethyl will show higher plus I effect. This methyl will show lower plus I effect. Therefore, this carbon is having more magnitude of positive charge. This carbon is having less magnitude of positive charge. This carbon is having less magnitude of positive charge because it is showing more positive effect. This ethyl group shows higher plus I effect. Therefore, this carbon is having lesser positive charge. This methyl group shows lower positive charge, lower plus I effect. Therefore, this carbon is having higher positive charge. Therefore, this is more reactive. This carbon is more reactive. This carbon is less reactive. Okay. So OH minus will attack which one? OH minus will attack which one in the sense OH minus will attack this carbonyl carbon. This pi bond shifting like this. Okay. So what we will get like this? What we will get? We will see. Here we will write ethyl group. Here we will write methyl group. This double bond O becomes O minus, and here what group comes means OH group comes. Here double bond O is there. Okay. What is the next step? We will see. In the next step, this lone pair is shifting as a pi bond. This bond shifting to this carbon. This C minus will attack this one. This bond shifting to here. Okay. So 6-membered ring becomes what in the sense 5-membered ring. 6-membered ring becomes 5-membered ring. Here at this place, this O minus will be there. This carbon is having the COOH. That COH will be there. And this carbon is having, this carbon, neighboring carbon is having ethyl group. Neighboring carbon is having ethyl group. Now the carbon which is having this O minus, that carbon is having methyl. Okay, this carbon is having O minus, this carbon is attached to this carbon is having methyl. So methyl we will write here. Then this is base, it is acid, therefore H plus transfer from here, H plus goes to this place. So this becomes OH, this is COOH becomes COO minus. It is ethyl group here, here methyl group here. Okay, here ethyl group, here methyl group. So and so product is obtained. This is called a benzylic acid rearrangement. Benzylic acid rearrangement we can say. Okay, next example we'll see for benzylic acid rearrangement. We'll take a like this cyclohexane ring. Here OMe group we will take OMe group. This O is ether. Here keto group we will give. Here also we will give keto group. Okay, like this we have taken. Now base is what in the sense methoxide is the base. Methoxide is the base. Methoxide base we have taken. So how the reaction is taking place, that we will see. Now this methoxide base has to attack carbonyl carbon. Which carbonyl carbon is more reactive, that we have to see. Which carbonyl carbon is more reactive, that we have to see. Here methyl group is there, it is showing plus I effect. This oxygen can show minus I effect. Here resonance not possible. Why? Because it is not benzene. Because of minus I effect, this carbon is having higher magnitude of positive charge. Because of this plus A effect, this carbon is having lesser magnitude of positive charge. This oxygen shows minus A effect. This oxygen shows minus A effect. Because of minus A effect of oxygen, this carbon is having higher magnitude of positive charge. Because of plus A effect of methyl, this carbon is showing lesser magnitude of positive charge. Okay. Now this O minus is attacking this carbon because this carbon is having more positive charge. This pi bond is shifting like this. So what we will get, we will see. Here we will write 6-membered ring. Here we will write OMe. Here we will write methyl group. Here we will write double bond O. Here we will write OMe and O minus. OMe, O minus we will write. This oxygen is having 3 lone pairs. Okay. So what is the next step? We will see. This lone pair becomes pi bond. This bond shifting to neighboring carbon. This neighboring carbon gets a negative charge attacking this carbonyl carbon. This bond is shifting to O. So the 6-membered ring becomes 5-membered ring. 5-membered ring. This double bond O becomes O minus. This carbon is having this carbon. That carbon is having one double bond O and OMe. This carbon is made bond with this carbon. It is having OMe. OMe. This carbon, neighboring carbon is having methyl group. That methyl group we are writing. Okay. So and so compound we got. So and so compound we are getting in this sorry. So and so compound we are getting in this benzylic acid rearrangement. Okay. Next continuation we will see. Here one phenyl ring will take. We will make this is as a biphenyl. Biphenyl means 2 phenyl rings linked through carbon-carbon link. Here what is there means here double bond O is there, here double bond O is there. Now OH minus we will take. Here this oxygen is having 3 lone pairs. Okay, OH minus we have taken. Now this O minus is attacking this carbon. This pi bond is shifting. Okay. So what we will get, we will see. Here we will say phenyl ring. Here we can write like this. This double bond O becomes O minus and here OH will be there. Here double bond O we will give. Double bond O we have given. Okay. So next step we will see. Next step what happens means this O minus, this O is having 3 lone pairs. This lone pair is going to this carbon. This bond pair goes to this carbon. Then C becomes C minus, that is attacking this carbon. This pi bond shifting to this carbon. Now we will give phenyl ring. Next phenyl ring. So we got biphenyl. This 6-membered becomes 5-membered. 6-membered becomes 5-membered. We will write. At this carbon, this double bond O and OH will be there. And now this carbon will take. This carbon is having O minus. This carbon is having this carbon. Okay, this carbon is having what in the sense double bond O and OH. Double bond O and OH. Now it is base, it is acid, therefore H plus transfer takes place. H plus transfer takes place. Here phenyl ring, here also phenyl ring. Here it is 5-membered ring. This is OH, it is COO minus. Okay, so and so compound we are getting in this benzylic acid rearrangement. Okay, next reaction we'll see. In the next reaction, we are taking alpha haloketone. We are taking alpha haloketone. Okay, so here carbonyl group CO, CCl, RR. It is called what in the sense alpha haloketone. Alpha haloketone. This is ketone at its alpha carbon. It is ketone functional group. This carbon is directly attached to functional group. Therefore, it is alpha carbon. Alpha carbon is having halogen. Therefore, alpha haloketone. Okay. Here alpha hydrogen not there. Alpha hydrogen not there in this case. Okay. To this, what is added in the sense methoxide is added. What is the reaction is possible here, that we'll see. Now, here we'll say that this methoxide oxygen is attacking this carbonyl carbon. This bond is migrating. Therefore, we are getting R dash C O minus. O minus is having 3 lone pairs. Here OMe will be there and C or R will be there. Okay. Next step, what happens means this lone pair becomes pi bond. This R minus takes this bond pair and attack this carbon. Here chlorine is there, that is leaving. Chlorine is leaving. Okay, Cl minus is leaving. So we are getting MEO, C double one O, C R dash R R. This is called a semi-benzylic rearrangement. It is called a semi-benzylic rearrangement. Semi-benzylic rearrangement we will say. Why semi-benzylic? In the sense it is not diketone. Benzylic acid rearrangement means benzyl means what? Alpha diketone. Alpha diketone. Here one ketone is there, one halogen is there. Therefore, it is called semi-benzylic rearrangement, we can say. Okay. Next reaction we will take, that is a Claisen-Schmidt reaction or Claisen reaction. Claisen-Schmidt reaction we will take. Claisen-Schmidt reaction. In this Claisen-Schmidt reaction, we are taking aldehyde lacking alpha hydrogen. Aldehyde not having alpha hydrogen, we are taking. Aldehyde not having alpha hydrogen, we are taking. Okay. Aldehyde not having alpha hydrogen, we are taking. Then we are taking aldehyde or ketone containing alpha hydrogen. Aldehyde or ketone containing alpha hydrogen, we are taking. Here we have taken aldehyde not having alpha hydrogen. Here we have taken aldehyde or ketone having alpha hydrogen, we are taken. Then it is treated with a dilute aqueous base. Dilute aqueous base. Okay, for example, base is what? In the sense alkoxide. To satisfy the negative charge, cation is there. What is the solvent we have taken? In the sense alcohol is the solvent we have taken. Okay. So here what is the reaction takes place, that we will see. Now this alkoxide will make this as carbanion. Now we will see the mechanism. We are seeing the mechanism. This alkoxide is making this as carbanion, not this one, because here alpha hydrogen not there. Here alpha hydrogen is there. So this is converting into what? In the sense carbanion. So here CH3 is there. Now we will take RO minus. This RO minus oxygen is having 3 lone pairs. So what happens means here it is abstracting proton. Therefore this RO minus becomes ROH. Now this bond is shifting to carbon. Therefore it becomes C minus. So this carbon is having lone pair and negative charge is there. It is carbanion. This carbanion is attacking benzaldehyde. That carbanion is attacking benzaldehyde. Okay. The carbanion is attacking benzaldehyde. This carbanion attacking this carbon, this pi bond is shifting. So what we will get in the sense CH3, C double bond O, CH2, CH2, CO minus H benzene ring. Okay, like this will be there. Then this O minus is abstracting proton. This O minus is abstracting proton from alcohol and becomes OH. So here phenyl ring, this CH, this O minus becomes OH, then CH2, CH2, C double bond O, CH3. Like this we are getting. Okay. Now what is this compound called? This is carbonyl group is present. Here carbonyl group is present, therefore it is carbonyl compound. Carbonyl group present, therefore carbonyl compound. Now this carbon is alpha carbon, this carbon is beta carbon. At beta carbon hydroxy is present. So beta hydroxy carbonyl compound we got. Next, this on warming. What happens means water molecule is leaving. From this beta hydroxy, carbonyl compound, water molecule is leaving, this bond is shifting, this bond is shifting. So water is leaving, so we are getting this phenyl ring, then CH double bond CH, C double bond O CH3. Okay, we are getting what in the sense carbonyl group is there, C double bond O in the sense carbonyl compound. We can call this as carbonyl compound. This is alpha carbon, it is beta carbon. Between alpha carbon and beta carbon pi bond is there, therefore we can call alpha beta unsaturated carbonyl compound. It is called alpha beta unsaturated carbonyl compound, we can say. Okay, so like this product is possible. So next reaction we'll see. This reaction is called Claisen reaction. In Claisen reaction, we have to take one aldehyde that is not having alpha hydrogen. Another aldehyde or ketone we have to take that has alpha hydrogen. Then in the presence of base, we have to treat the reaction. So next reaction we'll take. We are taking a benzaldehyde. We are taking benzaldehyde. Then we will take a CH3, C double bond O, phenyl ring. Phenyl ring. Okay, in the presence of base OH minus. What happens to the reaction? We'll see. This carbon is having alpha hydrogen, so we will make it as carbanion. This carbanion carbon will make a bond with this carbon. Therefore, that phenyl ring will take this O becomes OH. That O becomes OH, we can say. This CH3 becomes CH2. CH2. This CO phenyl ring will write as it is. CO phenyl ring we have written as it is. This is called a beta hydroxycarbonyl compound. From this, water is leaving on warming. Here pi bond is creating. Therefore, here this phenyl ring CH double bond CH CO phenyl ring. Okay, we are getting so on. So alpha beta unsaturated carbonyl compound we are getting. Alpha beta unsaturated carbonyl compound we got. Okay, next compound we will take. Here what is there means pi bond is there. Here two methyl groups are there. Here methyl group is there. Here what is there means carbonyl group is there. Aldehyde group is there. Now here no alpha hydrogen we can say. Here alpha hydrogen. It is alpha carbon is there. That alpha carbon is having one hydrogen. So alpha hydrogen is present here. Sir. Next we will take acetone. This acetone also having alpha hydrogen. This aldehyde is having alpha hydrogen. This acetone also having alpha hydrogen. We will take a base. Base is what in the sense ethoxide. Ethoxide we have taken, and the solvent is what in the sense ethanol. So this base can abstract proton from where? From here or from here in the sense from here but not here because it is carbon, double bonded carbon. It is sp2 hybridized, but this is sp3 hybridized. sp2 hybridized means electronegativity is more, so it will not give a H plus easily. It is giving H plus easily. Okay. Therefore, what is happening means this is converting into carbanion. This is converting into carbanion. This carbanion is attacking this carbonyl carbon. Okay. So in this part no change. So we can say here double one, here CH. This O minus becomes OH. Here CH2, COCH3. Like this you will get. Okay. This methyl group as it is present. Methyl group as it is present. Next. On warming, it is leaving water molecule. Water molecule will be leaving. So what we are getting in the sense, we are getting here CH double bond CH CO CH3. COCH3. So and so compound we are getting. Okay, sir. Next reaction we'll see condensation with the nitroalkanes. We'll see condensation with the nitroalkanes. Now we will take aldehyde or ketone. We are taking aldehyde or ketone. For example, benzaldehyde we are taking. Now we are taking nitroalkane which is having alpha hydrogen. We have taken nitroalkane, which is having alpha hydrogen. It is treated with base. What happens means this is alpha hydrogen. This alpha hydrogen is leaving, and this carbon becomes carbanion. This carbanion is attacking this carbon. Okay, this carbanion is attacking this carbon. Therefore, this O becomes OH. So phenyl ring will write this carbon with OH will write here H. This becomes carbanion. Therefore, CH2, CH2, then NO2. Okay. This one warming, water molecule is leaving. Water molecule is leaving like this. Therefore, we will get here CH double bond CH NO2. Okay. Alpha beta unsaturated compound we are getting. So, next reaction we'll see. Next reaction is called naming reaction called the Tishenko reaction. Tishenko reaction we are seeing. In the Tishenko reaction, we have to take what in the sense carbonyl compound we have taken. Carbonyl compound aldehyde we have taken. Then we have taken aluminum methoxide. Aluminum methoxide we have taken. So what is the product we will get here? Okay, in this Tishenko reaction that we'll see the mechanism for this. We are taking this aldehyde. This aldehyde we are taking, oxygen is having 3 lone pairs. Then aluminum methoxide will take. Aluminum methoxide we are taking. Now what happens means now this oxygen is donating lone pair to this aluminum. Okay, oxygen is contributing lone pair to this aluminum. So due to that, what happens means since it is contributing, this pi bond is shifting to oxygen. So we are getting RCH. A carbon is getting lost positive charge. A double bond becomes single bond. Oxygen is having 2 lone pairs. Here aluminum methoxide will say. So aluminum gets a negative charge because it has received the bond. Therefore, it is getting a negative charge. Without contributing electron, it has got bond. That's why. Okay. Now, another carbonyl group we will take. Another aldehyde we are taking. Another aldehyde we are taking. Now, how the reaction takes place in the sense this oxygen lone pair is attacking this carbon. Therefore, we will get a RCH single bond O. Their positive charge will be there, making a bond with CHR, this O, and aluminum ethoxide part will be there. Aluminum ethoxide part will be there. This aluminum is having negative charge. Okay. So what is the next step? We will see. Next step, what happens? That point we will see. This bond is shifting here. This hydrogen takes the bond pair and is shifting to this place. This bond is shifting to oxygen. Okay. That bond is shifting to oxygen. Therefore, this R will write. This CH becomes CH2 because when H minus comes and attacks, hydride shift. So CH2, double bond O becomes single bond O. Then this is a CR. This is a double bond O. That is a double bond O. Okay. So we are getting what in the sense ester we are getting. We are getting ester. This reaction is called what in the sense Tishenko reaction. So Tishenko reaction in the sense what we have to do means we have to take aldehyde 2 times. One aldehyde we will write like this. Another aldehyde we will write like this. Another aldehyde we are writing like this. What is a product? How to expect the product in the sense this hydrogen you give here and make this bond with this carbon. Okay, like this you do it. So we'll see this Tishenko reaction. Some reactions we'll see. We are taking acetaldehyde. In the Tishenko reaction, what is the product? We'll see. This acetaldehyde we'll write like this. Now we'll take another acetaldehyde. Another acetaldehyde. How to shift the bond in the sense this bond will shift here. This bond will shift between oxygen and carbon. Okay. This oxygen and this carbon. Therefore, CH3 CH2, this O, CO, CH3. It is a product. This is the ester product we got. Okay, we got a ester is a product. Okay, next reaction will take. Next reaction CH3, CH2, CHO. Tischenko reaction means aluminum ethoxide we have take as a catalyst. So what is the product? We'll see this CH3, CH2, C double bond O, H. Another will take HC double bond O, CH2, CH3. How the bond migration will be there means this will take the bond and shift here. This bond will shift and attacks this carbon. So we'll get a CH3, CH2, CH2, then O, CO, CH3, CH2, CH3. This is the product we will get. Okay. So next we will take suppose formaldehyde. This formaldehyde will take 2 times. Will take 2 times. How the reaction takes place? We'll see. This is attacking this carbon. This bond shift here and attacks this carbon. So we'll get this becomes CH3. Double bond O becomes single bond O, bond CHO. Bond CHO. Like this we'll get in this Tischenko reaction. Okay. So Tischenko reaction is like this. Okay. So Tischenko reaction means we are taking aldehyde, we are getting a ester. Aluminum ethoxide is the reactant. Aluminum ethoxide is the catalyst. Okay. So next we will see Michael addition. Next we are seeing Michael addition. Michael addition will take. We are taking what in the sense active methylene group we are taking. In this Michael addition, we have to take active methylene group. We have to take active methylene group. Active methylene group example is what in the sense malonic ester. Malonic ester. Active methylene group. Active methylene group example is what in the sense malonic ester we have to take. Then ethyl acetate we have to take. Ethyl acetate. Ethyl acetoacetate. So ethyl acetoacetate we have to take here. Okay. Ethyl acetoacetate. Ethyl acetoacetate we have to take. So now here ethyl acetoacetate. That means acetate in the sense one carbon has to be introduced. Okay. One carbon we have to introduce. So we will include a CH2. CH2 COOET. Okay. This is ethyl. It is acetate. It is aceto. Ethyl acetoacetate. Here this is CH2 group, methylene group. This is called active methylene group. Why it is called active methylene group? In the sense this carbon is having one electron withdrawing group right side, one electron withdrawing group left side. Therefore, it is active methylene group. This hydrogen will have more acidic nature. This hydrogen will have more acidic nature. Okay. Now we will take malonic ester. Malonic acid will take. It is malonic acid. It is malonic acid. We will convert this into ester form. We will convert this into ester form. Then we will call it as malonic ester. Here also, the CH2 group is called methylene. It is flanked by 2 electron withdrawing groups. One side electron withdrawing group, another side electron withdrawing group. Therefore, it is active methylene group is present in the malonic ester. Active methylene group is present in malonic ester. Then cyanoacetic ester. Next, we will take cyanoacetic ester. Cyanoacetic ester. This cyanoacetic ester is called is having active methylene group. How that we will see. Cyano NC acetic ester, cyanoacetic ester. Here this methylene group, one side electron withdrawing group, another side also electron withdrawing group, therefore active methylene group is present here. Then phenyl acetic ester. Then we are taking a phenyl acetic ester. Phenyl acetic ester. Phenyl group will give acetic group, acetate will say. Phenyl acetic ester. Okay. Now this CH2 is flanked by one electron withdrawing group here, one electron withdrawing group here. Therefore, it is active methylene group. Aliphatic nitro compound, benzyl cyanide. These are examples for active methylene group. Then we have take alpha beta unsaturated compound. Then we are taking alpha beta unsaturated compound. Example for that what? What is the example for alpha beta unsaturated compound that we are using for a Michael addition? Here phenyl ring, CH double one CH, then C double one O phenyl ring. This is what in the sense mesitile oxide. This is mesitile oxide we can say. So it is what in the sense mesitile oxide. Mesitile oxide we said. Okay. Next alpha beta unsaturated compound we will take. Here phenyl ring. Here CH double one CH. Here COOET. COET. Okay. This is also alpha beta unsaturated compound. Next alpha beta unsaturated compound we are using for Michael addition is this one. Alpha beta unsaturated compound. Next fumaric ester. Fumaric ester will take. Now fumaric acid will take. Fumaric acid will be two carboxylic groups will be there. It is called what in the sense fumaric acid. Fumaric acid. Now acid part will convert into ester part. Acid part will convert into ester part. So we will remove this H and we will remove this H. Instead of H, we will give some alkyl group. It is ester part, fumaric ester. Now the fumaric acid has become fumaric ester, we can say. Fumaric ester, okay. Then we'll see acrylic ester. Acrylic acid will take CH2 double bond CH COOH. It is acrylic acid. Acrylic acid. Acrylic ester in the sense this H is replaced by alkyl group. H is replaced by alkyl group. It is called acrylic ester. It is called acrylic ester. Next vinyl cyanide. Vinyl cyanide. Then acrolein. CH2 double one CH single one CHO. Acrolein. These are called alpha beta unsaturated compounds. Okay. So for Michael addition, we have to take active methylene group. Active methylene group compound we have take. Then alpha beta unsaturated compound we have take. Then we will get a. Then we can go for Michael addition. Okay. How the product will be there, that we'll see. Now first we are taking alpha beta unsaturated compound. One example, vinyl cyanide. Then active methylene group will take. Active methylene group compound we have taken, malonic ester we have taken. It is treated in the presence of base. So what is the product we will get, that we will see. So what is the product here in the sense? This base will abstract proton from active methylene group. So this base is abstracting proton from here. Therefore, we will write this ester part we will write. So base is what in the sense ethoxide. So this base is abstracting proton. This bond is shifting to carbon. Okay, so we got like this. So carbanion. So this is abstracting proton, therefore becomes ethanol. Here it becomes carbanion. Becomes carbanion, we can say. This is becoming carbanion. Ethanol is lost. Ethanol is lost. We got carbanion. This carbanion is attacking this vinyl cyanide. This carbanion is attacking vinyl cyanide. This carbanion is attacking vinyl cyanide. This lone pair attacks this carbon. This pi bond shift to this carbon. So we will get ETOOC, ETOOC, here CH, here CH2, single bond CH. This carbon is getting negative charge. This CN. Then this ethanol is giving H plus to this C minus. Therefore, we will get ETOOC, ETOOC, here CH, this CH2, this CH minus, this C minus becomes CH, C triple bond N. This C minus takes H plus from ethanol and C minus becomes CH. So and so compound is obtained. This is called what in the sense Michael addition. This is called Michael addition. So Michael addition in the sense from active methylene group, one nitrogen goes to this carbon. From solvent, one nitrogen comes here. Then this carbon bond is produced. Okay, that is called Michael addition. Now we will see one reaction. Vinyl cyanide will take vinyl cyanide. Then we will take ethyl acetoacetate. Ethyl acetoacetate will take ethyl acetoacetate. We are taking base ethoxide. So what will happen means this base will make this is as carbanion by abstracting proton. This carbanion will attack this carbon but not this carbon. Because of electron withdrawing group, this pi bond shifting to this side. Therefore, here more positive charge will be there. Therefore, carbanion will attack this carbon. So between this carbon and this carbon bond is produced. Then this carbon will get hydrogen from solvent. That is a product. Okay. So we will write what is a product we will write. So this NC will write. The CH becomes CH2. Double bond becomes single bond. This is what means CH2. It is making bond with this carbon. That is CH. COME, COOET. It is a Michael addition product. So this is about Michael addition we can say. Next we will see about Novi-Nagel reaction. Next we are seeing about the next naming reaction, Novi-Nagel reaction. KNOE VANAGEL. Novi-Nagel reaction we'll see. Here we are taking aldehyde or ketone that is not having alpha hydrogen. Aldehyde or ketone you take, but that should not have alpha hydrogen. Like this we are taking. Then this aldehyde or ketone not having alpha hydrogen is treated with a compound containing 2 alpha hydrogens. 2 alpha hydrogens should be there. That 2 alpha hydrogens should be flanked by 2 electron withdrawing groups. So 2 alpha hydrogens should be there. That should be flanked by 2 electron withdrawing groups. This Y and Y dash are electron withdrawing groups. Electron withdrawing groups, which and all possible in the sense for Y and Y dash, aldehyde is possible, ketone possible, ester possible, then carboxylic acid possible, then cyanide, then nitro, like this possible. Okay, electron withdrawing group should be there. Then it has to be treated with weak base. It has to be treated with weak base. Resultant loses water. Then on warming, decarboxylation takes place. Decarboxylation means removal of CO2. what we will get in the sense alpha beta unsaturated acid. Alpha beta unsaturated acid we are getting. Okay. Sorry. Now we will see the example for this one. This is aldehyde or ketone not having alpha hydrogen. Here two alpha hydrogen should be there, that is flanked by two electron withdrawing groups. So we will take malonic acid. Malonic acid is here.